Okay, so here's the next generation of similar triangles problem. They're gonna give you information to help you solve it, but it's gonna require more, a little deeper thought about how these problems are set up. So what we see is that there's a couple of triangles. We should know that they're similar using what we call angle-angle similarity theorem. So the idea is that if you know that you have two triangles and they have two angles that are the same, then they have to be similar triangles. So if I look at this triangle ABC, right, it has a right angle at triangle B. It's marked there, right? And then we have this triangle, or this angle CAB. When I look at the bigger triangle EAD, I notice that D is also a right angle. So now we have two angles right here, angle B and angle D, that are right angles. And I notice that it shares the same angle here, angle A. It's the same exact angle in both triangles, right? The only thing that's happened is it looks like, it's kind of been expanded out here somehow. So the dilation probably came, if this was formed by dilation, it would have been formed by a dilation with center at point A, and it just expanded it out. So what we know is that triangle, by angle-angle similarity, we know that triangle EAD is similar to triangle CAD. And that just means that or CAB rather, that means that the corresponding sides are similar in ratio. So we have side AB, let me write this out, okay? We have side AB, so we could say that side AB, right, over the measure of AD, so side AB over AD is going to be equal to, they want us to solve ED, so we know that CB would correspond to ED, so we would write CB is equal to CB over ED. Those are the two sides that correspond, and actually I should probably say DE, really is the better way to say it. But anyway, what is the measure of AB? So we can fill this in. What is the measure of AB? The measure of AB is 4. So this is where you kind of have to be a little bit careful, because a lot of times kids will say, what's the measure of AD? And they'll say 2. That's not true, right? It is 4 plus 2. So AD is the full length, all of this plus that. So that is 6. So we put 4 over 6. Is equal to CB measures 3 over, and DE or whatever measures X over X. So we cross multiply, we get 18 equals 4X. That's what it means to cross multiply. And then we divide by 4, and we get X, and this cancels, equals 18 over 4, which is equal to, right, 9 over 2, right, and then that's equal to, what's half of 9? 4.5. That's what X is equal to, okay? So we can go ahead and put that as our answer in for X, 4.5. See if we get another one just like it. Looks like the same kind of problem. So we have 5 over 10 is equal to 3 over X. That would be our ratio. We can write that out, and I'll just do it right next to it here. 5 over 10 is equal to 3 over X. If I cross multiply, I get 30, when I multiply this way, is equal to, 5 times X is 5X. And to solve for X, I would divide by 5 on both sides. And I get X equals, and that cancels, 30 divided by 5 is 6. So X equals 6. Okay? And it looks like just a set that's all going to be the same. 6 over 9 equals 1 over X. So 6, we'll do one more. I'll do this last. Actually, I'll do this one with the calculator so you can see it again. Okay, 6 over 9. I come over here. So 6 over 9 equals 1 over x. Solve for x. X equals 3/2, so that's 1.5, right? So I'll put that in as 1.5. 3/2 is 1 and 1/2, so 1.5. Okay, so that's pretty much how those are done. You're just going to look at those ratios and write them out, and you should be able to do this.